Hello everyone and welcome back to JavaScript Lessons and Codecademy. So last time we started looking at object constructors and classes. Today we're going to be looking at inheritance. So in object-oriented programming, inheritance allows one class to see and use the methods and properties of another class. So you can think of this it as a child being able to use his or her parents' money because the child inherits the money. You could also think about it as, for example, in a game, you have different types of enemies. All of them are inherited from an enemy class, but they all have different properties because they're not all exactly the same. And then you have a boss, which also comes from the class enemy, but the boss has special abilities, which no other enemy has, for example. So we will learn more about inheritance as we continue this lesson, but for now let's just refresh our memories about how classes and objects work. Oh, that's kind of boring, but okay. Create a class named animal. So here we have just simple with two properties, name and number of legs. What name should we give it? I'm just gonna say a name because I don't know what name to give it. And then we have num legs. I'm just gonna put 4. Actually, I'm just gonna go with dog to make it a bit simpler to follow. The animal constructor should have 2 arguments whose values are assigned to name and num legs. Wait, we need a class, right? Okay. So not an object, we need to create a class. So this dot name and this dot number of legs equals number of legs, as well as that should equal name. And here we have how do you create a constructor again? It was something like, I know it's a function. So you have you don't have var animal equals function, and we can take in name and number of legs as arguments. I think that's how you do it. Next, change the prototype of animal and add a method sayName that prints to the console, hi, my name is whatever it is. So how we do that is animal.prototype, and then it needs to be called sayName equals again another function, and it should say, it needs to say this. So I'll just copy that and then remove what needs removing and add what needs adding. This dot, what do we want it? We want the name. There we go. And then, is that it? Yep, there we go. So let's actually explain how this works then. So at first we create a class or a constructor which is called animal, and it takes in 2 arguments, name and number of legs. And we set those 2 for Penguin to be Captain Cook and 2. So name is Captain Cook and Captain Cook has 2 legs, if we follow that. Then when we create this method, that gets added to the whole constructor. So every animal constructor made after this has been added, or no, every animal object made will have this method in it, even if it was before or after this was made. So that means that Penguin is going to have this method inside it, which is why we can call it here. And when we call it, this is going to be referring to Penguin, because that's the last instance where we used an object. And we get the object's name by doing this, so in this case Captain Cook, and then that plus hi my name is gets printed out to our console. I hope that makes sense. If it doesn't, feel free to ask in the comments down below. I will be happy to explain it once more. So let's move on. Marching penguins, okay? I'm guessing we're going to making a big army of penguins then. Let's say we're dealing with a lot of penguins. It sure would be nice to create a penguin class so that perhaps later we can give it some methods unique to a penguin and not confuse it with the animal class. Yes. So create a brand new penguin class constructor starting in line 11. Okay. Penguin. Penguin is an animal, so it should also have the name and legs properties, as well as say name method that prints the same thing as animals say name method. So we need to get name and number of legs, and then here we need to do the same thing as here. Let's do that. And then we can copy this. I'm guessing that it's going to tell us the quicker way later on. For now we have to do it this way. We're not done with animals yet, so we have still included the animal constructor and its say name method. The last two lines test your penguin code. So our penguin code works just like our animal code worked before. But this isn't the most efficient way of doing it. So let's see if it's going to explain how we can do that. So creating a brand new penguin was nice, but we did end up reusing a lot of the same code as the animal class. This goes against the DRY principle of programming. Don't repeat yourself. So inheritance can help us here. A penguin is an animal, so they should have all the same properties and methods as animal. So whenever this X is a Y relationship exists, there's a good chance that we should be using inheritance. So as long as you have things repeated in both objects or both classes, you should use inheritance. Remember, inheritance lets us see and use properties and methods from another class. To say that penguin inherits from animal, we need to set penguin's prototype to be animal. Okay, let's see how that works then. So create a new penguin class. Or are we going to use it differently? The penguin constructor can be more unique than the generic animal one because all penguins have two legs. Your constructor should only take a name parameter, and within the constructor itself set this.numLegs to 2. So okay, I don't completely understand that, but let's try this out. Name and 2. I don't think this is going to work the way I'm doing it, but let's see. Okay, let's try it this way again then. NumLegs and this dot name equals name, and NumLegs equals 2. So therefore we actually don't need to take this from here. Set the penguin class's prototype to a new instance of animal by adding this line after you make the constructor. Okay. So let's see what that line does. Penguin.prototype equals new animal. Okay. This means that penguin inherits properties and methods from animal. Oops. Okay. Oh, we need this dot, not just numLegs equals that. There we go. So hopefully it explains this in a bit more detail, but I will try to explain it as best as I can right now from what I see. So here we create a penguin class, which again just gets the name given to it, but instead we get number of legs to always equal 2. And then using this line, we add this method to our penguin class as well. So instead of having to write it all out again, we just inherit it. Black and white penguin magic. Okay. Now for some black magic and to see the power of inheritance. We never defined a say name method for penguin, but what happens when we try to call it? So it should just work the same. So it should act just like this has been added to penguin. So create a penguin object with the variable name penguin and any name you would like. So let's do that. Nope, that's how you do it. Var penguin equals I don't know. It has to be penguin, and then what should be the name of the penguin? Peng. I don't know. And then we need to call this. Oops. Okay. Make sure to create a new penguin instance called penguin. Oh, new. I always forget that keyword. There we go. Hi, my name is Peng. I should call it Pengy. I don't know why I want to do that. Let's just do that. So basically what this is trying to prove is that we have taken everything that was in the animal constructor and put it in the penguin constructor as well, without having to type out the func method once again for penguin. So inheritance works. Penguin's properties and the prototype. We saw in the last exercise how penguin inherited the sayName method from animal. We now explore how classes can inherit properties as well. For simplicity, we've defined a new penguin class that doesn't inherit anything from animal. So we don't have an animal class here. We only have the penguin. So create an emperor class, okay, that takes a single name parameter and sets its name property to be this value. Don't set the number of legs property in the constructor. So function emperor, that's not how you spell emperor, takes a name, okay, oops, not a string, and it's not a colon, but it's curly brackets, and we need to say set this.name equals name. Similar to what we did in the previous exercise, make emperor inherit from penguin by setting the prototype of emperor to be penguin. So I believe this is how you do that. And we need to set that to equal to penguin. I have a feeling I'm doing something wrong. I guess we will see. Create a new emperor object that is an instance of the emperor class. So var why am I misspelling that completely? Equals new emperor, and we can give it the name MP because I don't know, because that's how I feel like it. With any name you'd like. Then use console.log to print the number of legs emperor has. This should have been inherited from penguin. So emperor.numLegs. Oops, okay. Let's see how we do the inheritance again. Equals prototype equals new animal. So I forgot the new keyword once more. And there's something wrong as well there. How penguin inherited from animal. Your code for emperor and penguin will be similar. So we have penguin.prototype equals new animal. So we need emperor.prototype equals new penguin. Okay, I don't know why this works. I will come back. I found what was wrong. I just made a typo. It's supposed to be prototype. If I can even spell that again now. Prototype. There we go. I spelled prototype or something. And then I had the code without the console log here. You're supposed now, because you need to log it, it needs to print it out. You just need to add a console.log there, and when you save and submit, everything works fine. So make sure you spell prototype correctly, or otherwise you will run into a syntax error, basically. Okay, so let's look at this then. Up the food, I mean prototype chain, okay? Penguin is an animal and an emperor penguin is a penguin. Are emperor penguins animals too? Well, yes they are. So the prototype chain in JavaScript knows this as well. If JavaScript encounters something it can't find in the current class's methods or properties, it looks up the prototype chain to see if it's defined in a class that it inherits from. So this keeps going upwards until it stops all the way at the top, the mighty object.prototype. More on this later. So by default, all classes inherit directly from object unless we change the class's prototype, like we've been doing for Penguin and Emperor. So if you remember in actually a few lessons, quite a bit of lessons ago, we used to make an object as equaling object. So you have var, we used to do something like this. So var new obj equals object. So that this is a class of its own, and that's the top class that you can have, and that's a predefined one made by JavaScript. So that's what it's basically saying here. So unless we change the class's prototype, like we've been doing so far for Penguin and Emperor. I think I read that already. Okay, so let's see our instructions then. Let's see how going up the prototype chain works. So we've defined some classes and inheritance patterns. So Emperor inherits from Penguin, which inherits from Animal. We've also created an instance of the Emperor class. So we have a class Animal here, we have a class Penguin here, and a class Emperor here. And then we have defined that Penguin inherits from Animal and that Emperor inherits from Penguin. So if you say that Emperor inherits from Penguin, because Penguin inherits from Animal, Emperor inherits from both Penguin and Animal. So var my Emperor equals new Emperor Jules, that is just initializing the object my Emperor, or a new variable my Emperor, which is an object Emperor. So without modifying anything other than lines 22 to 24, complete the console.log statements to print the appropriate responses. Okay, remember how the prototype chain works. If a property is not defined for a class, this class's prototype chain will be traversed upwards until one is found or not in a parent higher class. So console.log should print waddle waddle. So that should be just saying, and my Emperor dot saying, because that's the value of saying. I will just copy this because we will need to use that. Should print 2. So dot numLegs should print true. Okay, and we need to do dot is alive. So what you do here is saying, you look at the Emperor type. Can you see something that is waddle waddle? Yes, you can, because that's that. So you just use saying as my Emperor. Then you find 2, and then you can go up. Is there anything in Emperor? No, there isn't. Is there anything in Penguin that is 2? Yes, there is. Number of legs. So you use dot numLegs, and you still use my Emperor, because that's the only initialization of an object that you have. You wouldn't use Penguin. And then should print true. Do you have anything that can do that in Emperor? No, you don't. Do you have anything that can do that in Penguin? No, you don't. Do you have anything that can do that in Animal? Well, yes, you have. So you do is alive, and let's see if that works. As we can see, we get correct output. So we get waddle waddle, we get 2, and we get true. So I really hope that this makes sense. Inheritance is actually quite an interesting thing with object-oriented programming, because in games, as I mentioned before, you might need to inherit from things like enemies to bosses to, I don't know, extreme bosses maybe, and yeah, they're quite useful. So please do learn them, because you will probably be using them in programming quite a lot. Anything with objects is used quite widely. But that's it for today's lesson, guys. So please like if you liked it, subscribe, share it, and dislike if you didn't like it though. And please tell me how I can improve for next time. But until next time, thank you guys so much for watching, and goodbye.